Hello, my name is Leif Johannsen from Autophone. This is the second video in a series about what makes a cartridge good. The first video was about cartridge principles, focusing on moving magnet versus moving coil. We learned that moving magnet is about having a very small moving magnet moving within some really big coils, and we learned that the moving coil is about having a very small coil moving in a very strong magnetic field caused by a big magnet. Technologies is going to be the topic of this video, and technologies is about improving those systems. At Autophone, over many years, there's been an ongoing quest to improve the performance of these cartridges, both moving magnets and moving coils. And to do that, engineers have been looking into sort of imperfections in the system. Can we reduce some loss in the system? Can we reduce unwanted vibrations? Can we extend the range of how the different components are working? Sort of trying to extend the performance, and by that also extending the listening experience. We'll talk about 4 technologies today. Split pole pins, which are related to moving magnets. We'll talk about Element technology, which is about making houses with no unwanted vibrations. We'll talk about wide range damping, which is about enhancing the properties of the rubber suspensions in the cartridge. And we will talk about field stabilizing elements, which is about improving the properties of the magnetic field in the moving coils. All those technologies has the one and only quest to improve sound quality. The first technology I'm going to talk about is related to moving magnet cartridges. That is the technology that we call split pole pins. I here have a 2M rad. I'll take it apart so that we can identify the split pole pins inside the cartridge. Take off the stylus part. You have, of course, stylus, cantilever, and the small moving magnet in here. This is now the body. And inside here, inside the shielding, we have the coils. So now I need to take off this shielding. This. Now we can see this reddish color, which is copper wire. So we have a lot of copper wires on these 4 pins. You cannot see the pins. Imagine there's pins inside. We will see them in a second. Very thin wire, a lot of windings made on a machine. This is copper wire. We also use other kinds of wire for coils. There will be more about that in the materials video in this What Makes a Cartridge Good series. Let's see what happens if I take this one off here. I have prepared this one where it's easier to do. So I can now do like that, take off the plastic part. Now something is coming out here, and I can take off the front part as well. And now it's very clear that you can see 4 pins, or the end of sort of 4 pins. You cannot clearly see what kind of pins it is, but you can see the end of 4 pins. On each of these pins you have a coil. These pins are made out of a material which is really good at conducting magnetic field. So when this small magnet inside here, in the moving magnet, is moving inside the end of those 4 pins, we will have a magnetic field running down those pins and in fact up again on the other side. So inside the pins we will have some kind of changing magnetic field. The coils, just to show them to you, comes in pairs. This is a pair of coils, and one coil goes on one of these pins and the other one goes on the opposite one. So this could be for left channel, and the other pair of coils could be for right channel. So left channel, right channel, each of them have a pair of coils. The pins that we have inside the coils I have here. There are 2 different kind of pins I want to show you. This is a solid pin, so it's just pin, no hole in it. It's not a tube, it's a pin, solid pin. The other one here That's a tube. This is a tube, at least as you can see it. If you have a closer look, it's not only a tube, it is in fact a tube with a split down the side. So it's open along the side. So it's not really a tube, it's an open tube. It's made by folding a piece of metal and not really connecting them together. So this is what we call split pole pins, because they are split along the line, the length. And why do we do like this? This has something to do with magnetics. So if you have inside here, due to the movement of the magnet, because the stylus is moving in the groove, if you inside here move that magnet around, then this magnetic field that you will have running inside the pins, this magnetic field moves in the same way as the stylus in the groove. So in fact, you now have the musical signal from the groove moving along inside the pin, all four pins, left, right, channel. So the musical signal is in here. So you have a changing magnetic field. And if you have a changing magnetic field inside a conductive material, you will have loss. That is called eddy current loss. You can imagine that this is magnetic field inside those pins, and that will be varying according to the music. Then we will have some small currents induced along or around the magnetic field lines. And if you have current in a conducting material, you will have loss. You will lose some energy because you have some resistance. You will lose energy. And you don't want to lose energy, because if you lose energy, you lose musical signal, because the magnetic field is just the musical signal from the groove inside here. So you want to reduce that loss. So the massive pole pin that we have, that gives the possibility for really a lot of eddy currents, big eddy currents all over the place. If you make this tube and split it, then first of all, if you have a tube, you have a very thin wall, and inside here you only can have very tiny eddy currents. And now that it's split, you can even have an eddy current going around, because it's split here. So you reduce the possibility for eddy current, you reduce the loss, and this is related to the high frequencies. So you would improve the high frequency response of the cartridge by using the split pole pins. And you will improve musicality, the treble you will improve. So overall, the musical performance and the musical experience you will get out of a cartridge using the split pole pins compared to massive pole pins will be significantly improved. This is the story about the split pole pins that we have now been using for many years in all our hi-fi moving magnet cartridges. So improving sound quality, this is what this is all about. Next technology I'm going to talk about is selective laser melting, in short SLM. This is technology that we use to make our housings for our exclusive series cartridges. Shortly about housings for cartridges. In a way, people might think that this is sort of just a dumb part. You just need something to hold the generating system, and you need something to connect to the tone arm or head shell. So whatever, some mechanical part to connect those. But in fact, it's a very critical part, because that is the part that should ensure that the generating system is really kept totally still, and that the only things moving will be the stylus in the groove and the cantilever and the armature. Now we are talking about a moving coil cartridge. So we do not want any unwanted movement down there of the coil. Any unwanted movement of the coil not related to the stylus in the groove will of course make the musical experience worse. So it's about best possible working conditions. And that you can ensure by really having a stiff housing. So really stiff to keep everything into place. So that is what counts, to keep everything into place. But there's another thing that you not want to disturb the movement of the armature. And that is unwanted vibrations. And those unwanted vibrations will sort of come from the very nature of the cartridge, because you have stylus in the groove, you have a vibration of the cantilever and of the armature, so you have a lot of vibrations going on. And you do not want those unwanted vibrations to affect what music you're going to listen to. So again, you want to reduce that to make sure that the armature, the coil, is moving very precisely like the stylus in the groove. So this is why a housing is very important. Stiffness is easy to obtain for a housing. You can make it out of a piece of metal or ceramics or whatever, put it in a CNC machine and machine it, then you can have a really nice stiff housing, no problem to do that. But that kind of housing would not be able to reduce the unwanted vibrations. So you would have something softer in a way to reduce those unwanted vibrations. But these two properties is sort of contradicting each other. So you want something soft in a way to have the damping. You want it to be stiff, to have sort of control. So, and it's hard to have both of those at the same time. At a point, I visited one of our partners, Institute of Technology, and they introduced me to selective laser melting technology. Selective laser melting is about building, for our sake, a housing layer by layer. And for each layer you can determine how that would look both on the outside, which is what you see when the housing is finished, but also on the inside. So you have an extra degree of freedom in manufacturing those housings, so both on the outside and on the inside. So you can have a shell on the outside and the look that you want. You can have stiffness and the look. On the inside, you can have damping properties built up while producing this housing layer by layer. So this is a really big advantage by this additive manufacturing process, that you can determine what is inside the component as well. We made some housings for the cartridge that we were going to launch very soon at that point. That was back in 2008 for our 90th anniversary. MCA90 was made with a housing looking like this. The material is stainless steel, and these are two different housings now. One of them are sort of made totally solid, no damping inside, and the other one is made with damping inside. Now I'll drop them on this piece of rock, and then let's see how they will sound. That was one of them. That was the other one. We'll try again. Take this one. Sounds like you would expect from a solid metal part. A little bit like a bell. This is the other one. Definitely a lot different, a lot of damping. So you have, for both of them, you have stiffness, both of them. This one, so no damping and damping. So that is the main thing that you can really achieve with this selective laser melting technology: stiffness and damping at the same time. That was back 2008, and since then we have used this technology for a lot of our exclusive cartridges. So lining up here, you can see a raw body for the MC Diamond, you can see the MC Century, you can see the MC Verismo, and you can also see the body for the Binfeld TI over here. So to summarize, you are really able now to give the generating system, the cantilever, the stylus, coil, the best possible working condition. You are avoiding unwanted movement of the coil, you are avoiding unwanted vibration, so you are really enhancing the musical experience that you can get out by listening to a cartridge using this kind of selective laser melting housing. The next autophone technology that I'm going to talk about is the field stabilizing element, short FSE, field stabilizing element. That is used again in MC cartridges, or can be used in MC cartridges. As an example, I have a Verismo cartridge here with SLM, selective laser melting body, that I just talked about. And I have the motor system I can take out. I have loosened it. Normally it's glued very tightly into the housing. And then I have the magnetic system here. You can see the cantilever very clearly. And then you have a front yoke, you have a magnet, you have a rear yoke. And inside here, you cannot see it, you will have the armature with the coil wound on it. That is a very compact magnetic system that we also use in the Winfeld TI and also in the cadenzas. If I start to take this one apart, taking off the front yoke, I will end up with this thing. Still very small, but now you can see inside. And if you look close inside, you can very clearly see the cross-shaped armature with the coil on it. That is the point now that we are going to focus a little bit upon this armature. In most cartridges, that armature is made out of a magnetic material, some kind of iron alloy. That armature is sitting in the magnetic system, and that armature is moving because it's attached to the cantilever where you have the stylus in the groove. And the thing is that if you have a magnetic armature moving inside the magnetic system, then this movement is in fact changing the magnetic field around the armature. And that we do not want. When you recall when we talked about moving coil systems, this was about really having a big magnet and producing a stable magnetic field in an air gap where you could then have the coil on the armature moving. But in fact, when the magnetic armature is moving in the magnetic field, it will change the magnetic field. Only slightly, and only also at the very highest frequency. So when you're tracking a high frequency signal with your cartridge, with the stylus in the groove, the armature will be moving fast. And that is where you will have the most of these changes in the magnetic field. And of course, we do not want that. We do not want to have the magnetic field changing a little bit. We want it to be stable, to have the best possible sound quality, because stable magnetic field and the movement of the armature will give the perfect, clear musical signal. So how do we do that? How do we improve the stability of the magnetic field? And this is where this very genius component, this field stabilizing element technology developed years back by autophone engineers comes into the picture. So it's a small ring. Does not look like much. It's a small ring. It's a copper ring, so non-magnetic, and then it's silver coated. And it's silver coated copper to have the best possible conductivity. I want it to be very easy for current to flow in this one. That's the important properties of this. So the current should flow easily. So silver plated copper. So that is placed, you can see it slightly in here. If we look in here, you can see a small silver ring around here, and that is the edge of this field stabilizing element. So it's sitting in there, surrounding the armature. So you have the armature, and around that you will have this ring. And now we go to the physics, magnetic physics. So now when the armature is changing this magnetic field due to the movement, the system as such will try to counteract that change. And it does it in the way that a current is induced in this ring. So now in this ring you'll have a current induced. And that current will produce a magnetic field, a very weak magnetic field, but it will produce a magnetic field that will try to correct for the change that just happened in the magnetic field due to the movement of the armature. I know this sounds a little bit complicated, but so again, armature is moving, magnetic field is changing, current is induced in the field stabilizing element. That current produces a magnetic field to counteract the change that we just had, a change that we did not want to have. So therefore it's stabilizing. It's stabilizing the field, the magnetic field. So therefore FSE, field stabilizing element. That element has big impact on the sound at the high frequencies. So listening to music, you will have more resolution and better sound stage and stuff like that. It makes a big difference in your your experience when you listen to the cartridge, where you are stabilizing the magnetic field with this field stabilizing element. The next autophone technology I'm going to talk about is the wide range damping, WRD. That is an autophone technology also developed many years back, and as many of the technologies at autophone, this is also invented to improve the performance of the cartridge. So this is also relating to MC cartridges. Let's find out what this wide range damping is all about. First of all, I'll take this Verismo cartridge where I have a loosened generator system, magnetic system. Again, this is SLM, selective laser melting housing. So I have now the magnetic system, the generating system, whatever you want to call it. We have a rear yoke, magnet, front yoke, and you can see the cantilever sticking out. You have the stylus at the end. We need to open this one up to look inside. So they are happy to see each other. This one now is the same, but with the front yoke removed. And now you can look into it, and now you can clearly see the coil inside there with the windings. And you also see the silvery ring that we just talked about, which is the field stabilizing element. If we now go further into the system, removing the magnet and the field stabilizing element, we are ending up at something like this. I'll put it on a table in a second. We have the rear yoke. Again, of course, we have the cantilever and stylus, and you can see the armature. And then, very important, between the armature and the rear yoke, we have squeezed the suspension system. I'm calling it suspension system. That is, in fact, a very critical point in all of our MC cartridges, this interface between the moving parts. The moving parts will be the stylus, cantilever, and armature, and then all the stationary parts would then be the yokes and the housing and stuff like that. But we have an interface between those two, and that interface is extremely important for the performance of the cartridge. That interface is made from rubber, one piece or more pieces of rubber. That rubber is special autophone rubber. Autophone has its own development department for rubber production, test department for rubber, and also production of rubber, of course. So that is all in-house. So those rubber suspensions, we have 100% control what is going on, and we can give them exactly the properties that we want to. And again, this is the interface between the moving part and the stationary part, so extremely important. Normally, I'll put it down now, just to keep hands-free. Normally, you would have one rubber suspension between the armature and the rear yoke to sort of take care of all the stuff that this suspension has to take care of. And what is that? What properties do we want? We want to have some kind of compliance. We want it to be able to move. Of course, the cantilever and the stylus has to be able to move in the groove. So it has to be it has to be soft somehow. It has to have some kind of compliance. But very important at the same time, it has to have some damping properties, because the stylus in the groove on a vinyl record will have a resonance. That resonance we need to dampen because we don't want to hear it. It can be a very sort of large resonance, and we do not want that. So we need damping properties exactly in this rubber suspension. So two properties are important, sort of compliance and damping. And the thing is that the compliance will go for a soft rubber, but damping will go for a stiff rubber. So we need sort of to make a compromise. If you only have one rubber suspension, this is a compromise between the two worlds. And of course we can do that. We can have really nice rubber suspensions developed in our own department, and that's good. But we can also enhance the properties of this suspension system. Now I use the word system again, because in here we have this wide range damping, and that consists of two rubber suspensions plus one metal disc. Metal disc, which I would call a heavy disc because it's made out of a material with high density. So we have a metal disc squeezed in between two rubber suspensions. And in fact, if we have a look, I can put them on the table. This is what we have. We have, oh, they are of course small. We have the two rubber suspensions there and there. And then we have this metal disc. And now I can say that this metal disc is a platinum disc. So these three parts, two rubber suspensions and one platinum disc made as a sandwich, that is our wide range damping system. And what does that do? We want to have compliance. We want to have ability to move, especially at the low frequencies, because there the amplitude is the biggest. And if we look at how the behavior is of this wide range damping system, metal disc squeezed between those two rubber suspensions, then they would move as a whole, just like it would be one big rubber suspension. So in fact, the ability to move will be twice as much as for one rubber suspension because we have two rubber suspensions. So that's nice. So it's soft as we want it at the low frequencies. At the high frequencies, where we need the damping, then only one of the rubber suspensions will move because at the high frequencies, the platinum disc will prevent the other rubber suspension from taking part of the movement. So at high frequency, only one rubber suspension is into play. And this means that it's stiffer and you have better damping properties. So this is wide range, both at low and high frequencies, wide range damping system. And what do we get out of this wide range damping system? We do, of course, have this high compliance, so at low frequencies, high trackability and really powerful performance. That is one thing we get. At high frequency, where we have the damping that we need, we have really high clarity and we have a high resolution, really pleasant musical reproduction. So we can have both things at the same time because of this wide range damping that we can cover everything. So that is the advantage of using the autophone wide range damping system. You've now learned about 4 autophone technologies. 1 technology relating to the moving magnets and 3 technologies relating to moving coils. For the moving magnet, we learned about the split pole pins, where we saw that using those split pole pins would enhance the high frequency performance of the cartridge. For the MC cartridges, we learned about the selective laser melting technology, SLM, where we can build a housing with this selective laser melting technology and at the same time achieving 2 properties, damping and rigidity. We also learned about how to improve the magnetic field in the air gap in the moving coil cartridge by adding a component, the field stabilized element. And we also learned about how to improve the interface between the moving part and the stationary part, the suspension, by introducing a suspension system, the wide range damping system consisting of 2 rubber suspension and 1 disc in between. So in total we have looked at 3 different technologies for the MCs, covering both the housing and the magnetic system, and also the moving system. Two of them are in fact resolving compromises, because if you don't have the SLM technology, then the housing would typically be very rigid to sort of control the magnetic system and keep it steadily into place, but you would not have the damping needed. But using the SLM technology, you could have both at the same time, so resolving a compromise. And also for the wide range damping, where you normally would have to make a compromise between compliance and damping, wide range damping means that you can have both compliance and damping at the same time. So I hope you enjoyed to learn about these technologies. Autophone is very passionate about introducing technologies for their cartridges. We will go deeper into the different materials that we use in those technologies and in all of the cartridge in our next video about materials. Thank you for watching.